In most electrical systems, the neutral conductor is bonded to the ground at the service entrance panel only. This provides a low impedance path for fault currents to return to the source. Bonding the neutral to the ground at multiple locations, such as panel boards, can create a parallel path for fault currents, which can lead to hazardous conditions. The 5 amps of current in the ground terminal block and the 3 amps after disconnecting the neutral indicate current leakage, which can be caused by firstly, insulation damage, secondly, ground faults, and thirdly, improper bonding. The grounded lock nut and the feeder conduit with unbalanced current flowing on each side is also a concern. This can indicate a fault or poor electrical connection. This type of wiring configuration can lead to several potential hazards, including firstly, electrical shock. If a fault occurs, current could flow through unintended paths, increasing the risk of shock. Secondly, equipment damage. Current leakage can damage connected equipment. And thirdly, fire. Overheating due to excessive current flow can start a fire. Based on the information provided, it is highly advisable to disconnect the panels with this type of wiring. It is also recommended to firstly trace the grounding and bonding connections to identify the source of the current leakage. Secondly, test the insulation resistance of the conductors. And thirdly, consult with a qualified electrician or engineer to determine the best course of action. The presence of 5 amps on the ground terminal block of an electrical panel, coupled with their neutral conductor bonded to the ground block, raises significant safety concerns. In standard electrical practice, the neutral conductor should only be bonded to ground at the service entrance. Bonding the neutral to ground at multiple locations, such as within panel boards, creates a condition known as parallel grounding or multiple neutral ground bonds. This configuration can lead to undesirable consequences. The primary purpose of grounding is to provide a low impedance path for fault currents, ensuring that overcurrent protective devices, such as circuit breakers or fuses, quickly trip to energize a circuit in the event of a ground fault. When the neutral is bonded to ground at multiple points, it creates a parallel path for current to flow back to the source. This parallel path can divert current away from the intended grounding conductor, potentially overloading it. This can also result in elevated ground currents flowing through the grounding system, including equipment, grounding conductors, and metallic conduits. The observed 5 amps on the ground terminal block suggests that a portion of the neutral current is flowing through the grounding system instead of returning directly to the source through the neutral conductor. When the neutral conductor was disconnected, the ground current only dropped to 3 amps. This indicates that there are other sources of current leakage or ground faults contributing to the overall ground current. Several factors can contribute to current leakage and ground faults. These include insulation breakdown in conductors, faulty equipment, and improper wiring connections. Insulation breakdown occurs when the insulation surrounding a conductor deteriorates, allowing current to leak to ground. Faulty equipment can also introduce ground faults if internal components fail and create an unintended path for current to flow to ground. Improper wiring connections, such as loose connections or incorrect wiring configurations, can also contribute to ground faults. The presence of 5 amps on one side of the grounded lock nut of the feeder conduit and 2 amps on the other side, even with the screw tightened, further indicates a problem with the grounding system. This imbalance suggests that current is flowing through the conduit, which is not the intended path for current flow. The grounded lock nut should provide a secure electrical connection between the conduit and the enclosure, but it should not be carrying a significant amount of current. The fact that there is a current imbalance on either side of the lock nut suggests that there is a poor electrical connection or a fault in the conduit system. The historical context that this wiring configuration has been in place for 30 years is not a justification for maintaining it. Electrical codes and standards evolve over time to address new safety concerns and improve the performance of electrical systems. Even if the original installation complied with the codes in effect at the time, it may no longer meet current safety standards. It is essential to bring the electrical system into compliance with current codes and standards to ensure the safety of personnel and equipment. Disconnecting the neutral to ground bonds at the panel boards is a necessary first step to mitigate the potential hazards associated with this wiring configuration. However, it is crucial to thoroughly investigate the underlying causes of the ground current and address any issues with insulation breakdown, faulty equipment, or improper wiring connections. A qualified electrician or electrical engineer should conduct a comprehensive inspection of the electrical system to identify the source of the ground current and recommend appropriate corrective actions. The inspection should include insulation resistance testing of all conductors to identify any areas of insulation breakdown. The electrician should also check all equipment for ground faults and ensure that all wiring connections are tight and properly made. Furthermore, the grounding system should be thoroughly inspected to verify that it meets the requirements of the current electrical code. This includes ensuring that the grounding electrode system is properly installed and that all equipment grounding conductors are adequately sized and connected. Depending on the findings of the inspection, corrective actions may include replacing damaged conductors, repairing or replacing faulty equipment, and correcting any wiring errors. It may also be necessary to upgrade the grounding system to meet current code requirements. In addition to addressing the immediate safety concerns, it is also essential to educate building maintenance personnel about the dangers of multiple neutral ground bonds and the importance of maintaining a properly functioning electrical system. Regular inspections and maintenance can help to prevent future problems and ensure the continued safety of the electrical system. The NEC addresses grounding and bonding requirements extensively. Section 250.24 covers grounding service supplied alternating current systems. It states that the neutral conductor shall be grounded. This connection to ground provides a low impedance path for fault current to return to the source. However, this connection is intended to be made at the service equipment only. Subsequent connections between the neutral and ground at downstream panels can create parallel neutral paths. Section 250.28 covers bonding jumpers and requires that they be sized appropriately for the circuit. It is critical to verify that all bonding jumpers are intact and properly connected. Section 250.30 covers grounding requirements for separately derived systems such as generators or transformers. These systems must also be grounded in accordance with the NEC requirements. Section 250.50 addresses grounding electrode systems and specifies the types of grounding electrodes that are permitted, such as ground rods, ground plates, and metal water pipes. It is important to ensure that the grounding electrode system is properly installed and maintained. Section 250.167 provides guidance on grounding methods for equipment and enclosures. It requires that all metal equipment and enclosures be grounded to provide a path for fault current to return to the source. The presence of ground current in an electrical system is a serious safety concern that should be addressed promptly. Multiple neutral ground bonds can create parallel paths for current to flow, potentially overloading the grounding system and increasing the risk of electrical shock and fire. It is essential to disconnect any unintended neutral to ground bonds and thoroughly inspect the electrical system to identify and correct the underlying causes of the ground current. A qualified electrician or electrical engineer should be consulted to perform the inspection and recommend appropriate corrective actions. Continuous current flowing on the ground wire of an electrical system, especially when a neutral conductor is also bonded to the ground block, is indeed a strange and potentially dangerous situation. The typical electrical distribution system is designed to carry load current through the phase conductors and return that current through the neutral conductor. The ground wire, on the other hand, is designed to provide a path for fault current to flow back to the source in the event of an insulation failure or a short circuit. In a properly functioning system, the ground wire should not carry any continuous current. The fact that there are 5 amps flowing in the ground terminal block indicates that there is a problem with the wiring or the equipment connected to the system. The presence of a neutral conductor bonded to the ground block further exacerbates the problem. The neutral conductor is intended to be bonded to ground only at the service entrance or the main panel. Bonding the neutral to ground at multiple locations creates a parallel path for neutral current to flow back to the source. This parallel path can divert current away from the intended neutral conductor and cause it to flow through the ground wire. This can lead to several problems, including firstly, increased risk of electrical shock. If the ground wire becomes energized, it can pose a shock hazard to anyone who comes into contact with grounded metal objects. Secondly, equipment malfunction. Ground current can interfere with the operation of sensitive electronic equipment. And thirdly, fire hazard. Excessive ground current can cause the ground wire to overheat and potentially start a fire. The fact that disconnecting the neutral conductor only reduced the ground current to 3 amps suggests that there are other sources of ground current in the system. These sources could include insulation failures, faulty equipment, or improper wiring. The grounded lock nut on the feeder conduit is another area of concern. The fact that there is a current imbalance on either side of the lock nut indicates that the conduit is carrying current. The conduit is not intended to carry current and should only serve as a mechanical protection for the conductors. The flow of current through the conduit can cause it to overheat and potentially start a fire. In addition to the safety concerns, the presence of ground current can also violate electrical codes and standards. The NEC, for example, prohibits the use of the ground wire as a current-carrying conductor. It is also important to note that the age of the wiring is not a justification for ignoring the problem. Electrical codes and standards are constantly evolving to address new safety concerns and to improve the performance of electrical systems. Even if the wiring complied with the codes in effect at the time it was installed, it may no longer meet current safety standards. It is important to bring the wiring up to current code to ensure the safety of personnel and equipment. Given the potential dangers associated with this wiring configuration, it is advisable to disconnect the panels with this type of wiring. A qualified electrician should be called to inspect the wiring and to identify the source of the ground current. The electrician can then make the necessary repairs to correct the problem. In addition to inspecting the wiring, the electrician should also inspect the equipment connected to the system. Faulty equipment can be a source of ground current and should be repaired or replaced. The electrician should also verify that all wiring connections are tight and properly made. Loose connections can also contribute to ground current. Finally, the electrician should verify that the grounding system is properly installed and that it meets the requirements of the current electrical code. A properly installed grounding system is essential for preventing electrical shock and for protecting equipment from damage. The presence of 5 amps on the ground terminal block of an electrical panel, coupled with a neutral conductor bonded to the ground block, indicates a serious and potentially dangerous situation. It violates standard electrical practices and poses several risks, including electrical shock, equipment damage, and fire hazards. In a typical electrical system, the neutral conductor is bonded to ground at the service entrance, providing a low impedance path for fault currents to return to the source. This bond ensures that in the event of a ground fault, the fault current will flow back to the source, tripping the circuit breaker or blowing the fuse, thereby de-energizing the circuit and preventing electrical shock. Bonding the neutral to ground at multiple locations, such as at panel boards, creates parallel paths for neutral current to flow. This can lead to several undesirable consequences. Firstly, it can cause a portion of the neutral current to flow through the grounding system, including the equipment grounding conductors and the metallic conduit. This is precisely what appears to be happening in this case, with 5 amps flowing on the ground terminal block. Secondly, it can overload the grounding system, potentially causing it to overheat and creating a fire hazard. Thirdly, it can interfere with the operation of ground fault circuit interrupters, or GFCIs, which are designed to detect small imbalances in current and trip the circuit to prevent electrical shock. If the neutral is bonded to ground at multiple locations, the GFCI may not be able to detect the imbalance, rendering it ineffective. The fact that disconnecting the neutral conductor only reduced the ground current to 3 amps suggests that there are other sources of ground current in the system, in addition to the neutral ground bond. These sources could include insulation breakdown, faulty equipment, or improper wiring. Insulation breakdown occurs when the insulation surrounding a conductor deteriorates, allowing current to leak to ground. Faulty equipment can also introduce ground faults if internal components fail and create an unintended path for current to flow to ground. Improper wiring can also contribute to ground faults, for example, if a conductor is accidentally touching a grounded metal surface. The grounded lock nut on the feeder conduit with unbalanced current flowing on each side is another indication of a problem with the grounding system. The lock nut should provide a secure electrical connection between the conduit and the enclosure, but it should not be carrying a significant amount of current. The fact that there is a current imbalance on either side of the lock nut suggests that there is a poor electrical connection or a fault in the conduit system. Given the potential dangers associated with this wiring configuration, it is highly advisable to disconnect the panels with this type of wiring. This will eliminate the parallel neutral paths and reduce the risk of electrical shock, equipment damage, and fire hazards. However, disconnecting the panels is only a temporary solution. It is essential to thoroughly investigate the underlying causes of the ground current and address any issues with insulation breakdown, faulty equipment, or improper wiring. A qualified electrician or electrical engineer should conduct a comprehensive inspection of the electrical system to identify the source of the ground current and recommend appropriate corrective actions. The inspection should include, firstly, insulation resistance testing of all conductors to identify any areas of insulation breakdown, secondly, testing all equipment for ground faults, and thirdly, verifying that all wiring connections are tight and properly made. Depending on the findings of the inspection, corrective actions may include, firstly, replacing damaged conductors, secondly, repairing or replacing faulty equipment, and thirdly, correcting any wiring errors. The grounded lock nut on the feeder conduit should also be inspected and repaired or replaced if necessary. The presence of 5 amps on the ground terminal block, the neutral conductor bonded to the ground block, and the unbalanced current on the grounded lock nut all point to a potentially dangerous wiring configuration that requires immediate attention. Disconnecting the panels with this type of wiring and conducting a thorough investigation by a qualified electrician are essential to ensure the safety of personnel and equipment.